Alright, this video is meant to help you understand how to simplify radicals when you're dealing with addition and subtraction. And basically the idea is if you had a problem like the one at the bottom here, the 3 root 7 plus 6 root 7, what we want to know is how do we deal with that? How can we simplify that, or basically add the two terms together? And what's required are essentially like terms. So the two expressions you're looking at up at the top are going to help us out. If we had an expression like 3x plus 6x, basically we just take a look at it and say, well, hey, if they're both x to the first, then we can add their coefficients. 3x plus 6x comes out to 9x. Because again, the x is sort of considered a like term. We could factor that x out if we really wanted to, such as if we said x times the quantity, and if I remove the x from both parts, this leaves us with 3 plus 6, and basically that becomes 9 times x, or 9x. We can do the same thing with the expression at the right. We just need to look for the like terms. We've got 3x squared minus 12x squared. We've also got 6x plus 2x. So if we add our like terms together, our x to the firsts become 8x in blue there, and our 3x squared minus 12x squared, don't forget the negative, the 3 minus 12 will become a negative 9x squared. Well, if we consider root 7 to be similar to that x in the first example, again, we can take that root 7, we can factor it out, which leaves us with a 3 and a 6, essentially saying we've got 3 root 7s plus 6 root 7s, which essentially gives us 9 root 7s. We just need to treat our square root as a like term. What's required is it's the same type of root, they're both square roots, and it's the same radicand, or the same number underneath. We've got a 7 in the first one and a 7 in the second one. Now, where it gets a little trickier is when our roots aren't alike yet. Again, in the example shown here, we've got a 20 and a 125. They're both square roots, but again, I cannot add roots when they're not like roots. They have to both be the same root and the same radicand. So the first thing we're going to do is practice simplifying a little bit. If we took root 20 and we broke that down, you're going to have 5 times 4, and then 4 would be a 2 times another 2. Now remember, that means that we essentially have the square root of 2 squared times 5, and the square root of 2 squared is really just a 2, with a leftover 5 that didn't have a partner, so it's going to stay inside the root. Now, 125, we can do the same thing. 125 can break into 5 and a 25, 5 being prime, and 25, again, is another couple of 5s, which means, again, partners end up on the outside. So if I take 2 of those 5s, that's going to end up outside, and my leftover 5 ends up underneath. Well, if we go back to our example then, we've got 8 times 2 root 5, because that's essentially what root 20 was equal to, right? At 2 root 5, plus root 125 became 5 square root of 5. Well, simplify the first a little bit. We've got 8 times 2 becomes a 16, multiplied on the outside of that root, plus 5 the square root of 5. And now that we've got those like roots again, we can add the coefficients. I have 16 root 5s plus 5 root 5s, which makes for 21 square root of 5s. Treat that root 5, again, that sort of like portion, right, here and here, just as a variable. We have 16 of those yellow, that highlighted yellow root 5, plus 5 of that highlighted yellow root 5. And again, we're just adding those like terms to come up with our simplified statement. I hope that helps you with square roots and adding and subtracting. Subtracting would work the same way. Again, we're just adding like terms. If you have any questions, make sure you see your teacher. Otherwise, good luck, and as always, have fun.